Hi, welcome to today's lecture. I'm going over the take-home final practice final exam. As with the actual final, you have these instructions you need to read over. Make sure to write your name on the cover of each subsequent page. It consists of 14 pages. Make sure you have all of them. Answer the questions in the spaces provided after each question. And you can continue your work on the back of the page. You have 2 hours to complete this exam. And once you begin it, you are not permitted to use your textbook, notes, phones, or other supplemental devices. However, you can use a table of Laplace transforms that is on the next page. When you're finished, you can upload a copy in Dropbox by May 13th. Okay. That's for the actual final, not the practice one. And of course, you can assign this declaration of academic integrity, just saying you completed the exam in 2 hours or 120 minutes without any unauthorized material or devices. Didn't use anything for notes except for the page of the class transforms on the next page. Here's a short table of the class transforms. It's taken directly from the textbook, and it's going to be useful for the 6th problem. There's 6 problems in this exam and 1 extra credit problem. The first problem is to solve the following initial value problem. V dv dt is negative 16t plus tv squared, where v of 0 is equal to 5. This is the initial condition. Notice both these terms, negative 16t and tv squared, have a factor t in them. When we factor out t, we get negative 16 plus v squared. We're next going to multiply both sides by 1 over negative 16 plus v squared times dt. We get v over negative 16 plus v squared times dv is t dt. So we've separated the variables. We can now integrate both sides to get the following. Integral v over negative 16 plus v squared dv equals the integral of t dt. 1/2 ln of v squared minus 16 is an antiderivative of v over negative 16 plus v squared. With respect to v, t squared over 2, we've seen this a bunch of times, is an antiderivative of t with respect to t. So we replace this integral with the antiderivative, 1/2 ln of v squared minus 16. We replace this integral with the antiderivative t squared over 2 plus c. Next, multiply both sides by 2, and we put both sides in the power v. When you multiply both sides of this equation by 2, you get ln of v squared minus 16 equals t squared plus 2c. And now when we put the left-hand side in the power v, we return what's inside the natural logarithm, v squared minus 16. So we get v squared minus 16 is equal to e to the t squared plus 2c. Solve for v squared, a e to the t squared plus 16. A is e to the 2c. We're given that when t is 0, v is 5. When we plug these numbers in, we get 25 is a times e to the 0 squared plus 16, which is equal to a times e to the 0 plus 16, or a plus 16. Therefore, a is equal to 25 minus 16, which is 9. We plug in the value for a is 9, and we get this final solution. V squared equals 9, e to the t squared plus 16. Next problem. So notice that technique was separation of variables. This technique solved the initial value problem xy dy dx plus x squared equals y squared. Y of 1 is 3. This is going to be the technique of homogeneous differential equations, making a substitution and then using separation of variables. When we multiply both sides of the equation by dx, what do we get? xy dy plus x squared equals y squared dx. That means xy dx plus x squared minus y squared dx equals 0. P of xy is x squared minus y squared. Q of xy is x times y. We check when we plug in tx, comma ty, into p, we can pull out t squared. Same thing for q. When we replace x and y with tx and ty respectively, we can pull out t squared. We're left with x times y. What this means is that the equation is homogeneous of degree 2. Make the substitution, u is y over x, y is ux, therefore dy is x du plus u dx. So what do we get? X ux times x du plus u dx plus x squared minus u parentheses ux squared times dx equals 0. Therefore, ux squared times x du plus u dx plus x squared minus u squared dx equals 0. So ux cubed du plus u squared x squared dx plus x squared minus u squared x squared dx is 0. These terms, if you notice, u squared x squared dx and minus u squared x squared dx are the additive inverses of each other. They cancel. What we're left with is u x cubed du and x squared dx. Now we divide both sides by x cubed. We get u du plus 1 over x dx is 0. So slap on an integral to both sides. We get antiderivative or indefinite integral of u du plus indefinite integral of 1 over x dx is a constant. This indefinite integral or antiderivative of u is u squared over 2. Antiderivative of 1 over x is ln of absolute value of x. Next, we solve for u squared. U squared is equal to 2c minus 2 ln of absolute value of x. Since u is y over x, we just replace u squared with y squared over x squared. That means y squared is equal to 2c times x squared minus 2x times ln of x. That's just multiplying both sides of this equation by x squared. What are we given? The initial condition y of 1 is 3, so we can solve for 2c. 3 squared equals 9, which equals 2c minus 2 times ln of 1, which is equal to 2c. Plugging this back into the equation for y squared gives the following. Y squared equals 9x squared minus 2x squared times ln of absolute value of x. 2c was just replaced with 9. And there's our solution. Let's go on to the third problem. Solve the initial value problem. dv dq plus 16t v equals 2t v squared, where v of 1 is equal to 2. It's the initial condition. This is a Bernoulli equation. So that's the third topic. It was covered on the first midterm exam. And we have n is equal to 2. So we're going to multiply both sides of 1 minus n times v to the negative n, which is the same as negative v to the negative 2. We get negative v to the minus 2 dv dt minus 16t v to the negative 1 is negative 2t. v squared times v to the negative 2, of course, is just 1. We're going to now set u is v to the minus 1, so u prime is negative v to the negative 2 times dv dt. The equation therefore becomes the following. U prime minus 16tu equals negative 2t. This, as with all Bernoulli equations, once you make the substitution, the subsequent equation can be solved using an integrating factor. Antiderivative of minus 16t is minus 8t squared. We raise e to that power, and we get our integrating factor. So we multiply both sides of the equation by e to the minus 8t squared. We get e to the minus 8t squared u prime minus 16 e to the minus 8t squared u is negative 2t e to the minus 8t squared. E to the minus 8t squared u in parentheses prime is negative 2t e to the minus 8t squared. So we get e to the minus 8t squared u equals 1/8 e to the minus 8t squared plus a constant. Now we multiply both sides by e to the 8t squared. We get u is 1/8 plus c e to the 8t squared. We replace u with 1 over v. We get 1 over v equals 1 over 8 plus c e to the 8t squared. This is the general solution of this equation. But we're given an initial condition, so we can use that initial condition to solve for this constant c. When we plug the initial condition, v of 1 is 2, we get 1 over 2 is equal to 1 over 8 plus c e to the 8 times 1 squared, which is just e to the 8. 1/2 minus 1/8 is 3/8 because 1/2 is 4/8. 4 minus 1 is 3. So we can solve for c. It's 3/8 e to the minus 8. We put this value for c back into the formula for v, and we get 1 over v is negative 1 over 8 plus 3 over 8 e to the 8t squared minus 8. That means v of t is 1 over negative 1 over 8 plus 3 over 8 e to the 8t squared minus 8. Therefore, v of t is 8 over negative 1 plus 3 e to the 8t squared minus 8.